Tonight I'm going to be teaching about frequency and white space within the realm of communication technology. In order to be able to teach about frequency and white space, I've found it important that I understand a few other terms as well. So I'll briefly describe those as well. The terms that we'll cover are frequency, white space, spectrum, bandwidth, and interference. And all these have a lot of interplay together. That's why I feel they're important to understand. So we'll dive right into it. So first, what really is frequency? Frequency is described as how many times something occurs over a period of time. If you've ever seen a graph with sort of oscillations like this, that describes a frequency. There's a high end and a low end of the frequency, and this is oftentimes described as one period. I guess the time that it takes for it to go through one entire oscillation of getting from one spot and then back to its same spot again. We have amplitude, which is the distance from its median spot up to the top, and the period as I described already. And frequencies are used to carry information. With being in a digital age and how information is really just a series of zeros and ones, it can be somewhat easily imagined of how a frequency could carry information when it's only zeros and ones. That it could potentially be that a 1 is at the high end, a 0 is at the low end, and there's lots of different ways to do that. I'm not going to go into a lot of detail on that because that could be spoken on for a long time, and I also don't understand it all that much. But basically understand that frequency is used to carry data, and it does that through some cool ways. Then we move on to spectrum. Frequencies can operate at different speeds. A unit that is often used within frequency is the hertz. Hertz is equal, or I guess 1 hertz is equal to 1 per second. Within the realm of 5G mobile data, there's a few separate realms within 5G itself, but looking at the realm that's the fastest, that will operate across a spectrum of 20 gigahertz to 54 gigahertz. So what spectrum is it tells us specifically over what frequencies something is operating. And that takes us a little bit to bandwidth. So we can consider this here our spectrum. And if we consider this our spectrum, then we can consider this lower number here, the 34 gigahertz, our bandwidth. Bandwidth will not give us specific information as to over what frequency something is operating. Rather, it'll tell us the whole width of space of frequency that operation is taking up. Namely, 5G operating from 20 to 54 gigahertz. We know that that's then a bandwidth of 34 gigahertz, which is huge. And that's why it allows for such high-speed things to occur. And one of the purposes for needing a lot of bandwidth is because of interference. I'm going to erase this really quick so that we can look at interference a little bit closer. Now, we can imagine interference and seeing that we have, say we have one frequency oscillating like this and carrying its information to the user who needs it, coming from the important person who has sent it. And we can imagine that we have another frequency that's going a bit slower and coming like this. Now at each of these points is going to experience some interference in which data from one source will be confounded with data from that other source, and those zeros and ones are likely to get all jumbled up or mixed up, and it'll be hard to differentiate which is which, or maybe even impossible. Some of you may have experienced this before if you've ever tried tuning an old radio, and you get to a point where you feel like you're getting multiple stations at once. You're experiencing some interference there. And measures have to be taken so that interference doesn't occur, and so that information can still be kept safe, as well as in its true form and accurate. Otherwise, life can get confusing. And what's the use of all our technology anyway, if it doesn't actually accomplish its purpose? So interference then brings us to whitespace. Whitespace applies specifically within the spectrum that TV channels use. So let's say that we have this spectrum here, and within, at this certain frequency here, we have channel 6 operating. At this frequency, we got channel 7. This frequency here, we got channel 12. And then say, I don't know, we have channel 4. Who knows if they're actually in that order, but this just works for the purpose. White space is what it looks like on this board. It's all this white space, which is now becoming green, which is just unused. The TV industry or television industry has all this spectrum or bandwidth allotted to them, and there's so much that's being unused. But that could really be used to accomplish a lot of things. People could receive better internet connections using this white space here. Lots of people have talked about the Internet of Things, or different objects being connected together to be able to communicate one with another through frequency waves. That can allow for real autonomous driving and different things of that sort. And this space could potentially be used for that. It wasn't until 2010, though, that white space was actually legally made able to be used by unlicensed people, or really by the public. And so now, since 2010, we have access to all of this space within that range. And the question now is, like, what are we going to do with it? Within our class, one of our assignments, or our capstone, is to create a new communication technology. One question that we could consider is, can we make use of this white space with whatever technology we choose to create? It's really an untapped source of potential that some people have begun to try to tap into some more, and we're really just at the beginning of it. And the limits are really endless with how much we can do with that white space, and really within the realms of frequency in general. We're seeing a lot of ground be broken with 5G now, and what will potentially be possible with that. There's still lots of work to go there if those speeds that they reach in the spectrum of 20 to 54 gigahertz will be accomplished, with how much has to be done there. But we're really experiencing some amazing things. So I hope that this was simple yet instructive, and that you can feel encouraged to learn a little bit more, and also feel a bit more confident in going and reading a little bit more, and hopefully understanding what's going on. Anyways, thanks.